principle of a machine, or on which principle all these machines are actually work. So the main principle is conservation of energy. What is the definition of conservation of energy? Conservation of energy states that energy can neither be created nor be destroyed. It can be transferred from one point to another point. So here if I'm talking about for an ideal machine, output energy is equals to input energy. What is the meaning of output energy? Output energy means work obtained at a load point. So work is done by the machine on the load. This is called work output. Okay, so the energy at the load point, that is called output energy. So this is basically load into displacement of point of application of load, or simply I can write load into displacement of load. And what is input energy? Input energy is energy given to a machine. So what is the input energy? Input energy is equal to work done at a effort point. At the effort point we are giving a force, or we are giving the energy to a machine. So work done at the effort point, this is called input energy. So this is basically effort into displacement of the point of application of effort, or I can write effort into displacement of effort. Now for the ideal machine, there is no losses. If there is no losses, we will not consider any losses. For ideal machine, efficiency is 100%. But in case of actual scenario, efficiency is not 100% because some losses are there. For an ideal machine, if we are giving 100 joule of energy to a machine, then at the load point whole 100 joule energy is converted and we are getting 100 joule energy from the machine. But in case of actual machine, this is not possible. For an actual machine, output energy is equals to input energy minus some losses. So what are these losses? One by one we will see. But for example, here you have given 100 joule energy and 20 joule of energy is actually wasted. Okay, so output energy at the effort point, or sorry, at the load point, we are getting only 80 joule of energy. So this is basically a loss of energy. So what are those losses? One by one we will see. So losses, we have weight of a moving part. Actually we are neglecting the moving part in the ideal machine, but in the actual machine, weight of moving part we have to consider. In the ideal machine, we have neglected the friction between the moving part, but in case of actual machine, friction is there between the moving part. Next we have string is not perfectly elastic. In case of ideal machine, string is perfectly elastic, and in case of actual machine, string is not perfectly elastic. What is the meaning of perfectly elastic? Carefully see. For example, we have some string, okay, a rope is there for example. So for example, its length is 50 centimeter. Now under the force, its length gets increased up to, for example, 52 centimeter. Now when you will remove the force, if the rope or a string come back to their same length, same position, that string is called perfectly elastic. Or in some cases, for example, in actual scenario, when you are applying the force and remove the force, there is little bit increase in the length of the rope. For example, it becomes 50 centimeter. Now the string is not perfectly elastic. So due to this not perfectly elastic, it is considered under a loss. Next we have parts are not perfectly rigid. What is the meaning of this? For example, one iron nut is there. When iron nut, we are applying force on the iron nut get deformed, it's changed its shape. So due to the change in the shape and size, then there is also considered it as a loss. So these are the losses. Out of these four losses, friction between moving part is a major loss. Okay,